Thank you so much for that that intro, Mohan. It's impossible for me to disappoint everyone now with that lead-in. No, really though, very happy to be here today. Really appreciate everyone attending, and I'm excited to talk to you about kind of the trends that we've been seeing internally at DigitalOcean when it comes to blockchain, and specifically how it obviously relates to infrastructure in blockchain. So thank you for that. Go ahead and next slide, Mohan. Excellent. So I wanted to first talk about a few key terms that will be just important to understand when we talk about the pros and cons of various things when it comes to infrastructure for blockchain. So first up at the top here is CPU steal. Now this is a term that you might be familiar with, but if you're not, what this means is a processor can handle so many instructions at one time, and when we send it more instructions than it can handle at a time, it has to queue up some of those instructions. And what we call that CPU steal. It's like stolen time from your processor that you can't get back. Now, it's possible for you to cause your own steal, so if you're just sending too much to your own processor, but it's also possible to see CPU steal on shared CPU plans, which is why it's mentioned here. It is a killer for performance if you are trying to get the most out of your shared CPU plans and you're seeing a bunch of steal. The next term I want to talk about is full nodes, and we'll talk about light nodes at the same time. Just to give you guys, I know we had some blockchain beginners from the poll at the beginning. A full node is a blockchain node that contains a copy of the entire blockchain, and as a result can be used to validate against new transactions on the blockchain. So a full node, just think of a full node as kind of the big beefy node that blockchains need to have in the back end. And then light nodes are more of the front end nodes. These have much lower resource requirements. They don't store the whole blockchain, and they can tolerate a little more CPU steal, whereas a full node, you really don't want that to have any CPU steal at all. A smart contract is something we'll talk about just a little bit. This doesn't relate too much to infrastructure, but a smart contract is an automated action that can be taken on the blockchain itself. So essentially, a little code you can put into a blockchain. So Ethereum is very famous for their smart contract. Sharding is where we split a blockchain network into multiple different portions or shards, and each of those shards maintains an independent state. And finally, bridges are ways to connect different blockchain networks. So we'll talk about Pocket later on and kind of how, in general, how they work and what they do. But bridges facilitate cross-chain token transfers, which is a really interesting use case of blockchain. So we'll talk about all that, but I wanted to give you those initial terms so you understand kind of where we're coming from on a base level. Next slide, please. So, when we talk about trends in blockchain, and can you click through a little bit, Mohan, just once? So when we talk about trends in blockchain, first we talk about the ability to scale, right? So the ability to scale, as Alex said before, absolutely critical. There's a reason blockchain isn't running a bunch on bare metal. It's because bare metal is super hard to scale. You have to plan out way in advance when you're gonna scale for bare metal, and you're committed to that usage, things like that. With cloud deployment, you can scale much more dynamically, which is absolutely critical for these blockchain workloads. The next thing is that the workloads are automation heavy, and so we say this to say most people are not going in and manually deploying all of their blockchain nodes once they get to a certain scale, right? Now, when you're first starting out, of course, you're gonna test out your deployments yourself, but there's gonna get to a point where you're gonna want to automate the tasks of the management of your blockchain network, right? So these are things like APIs, things like Terraform, things like Ansible, Packer, Salt, Chef, all these other tools which can be used to set up these blockchain nodes and other services that you're going to be using to support your blockchain. We've also seen that the growth of blockchains is bursty, and this is another reason why scaling dynamically is critical, because you may not see much scale for a few months, and then suddenly some renegade billionaire tweets about your cryptocurrency, and boom, you're blowing up. Your network is getting a lot more traffic than it was before. You're getting a lot more demand, and you can see that growth shoot up. So that's absolutely important, again, in the scale conversation. Additionally, we've seen the market is moving towards proof-of-stake workloads. I don't think this surprises anyone who's familiar with the blockchain space. Proof of work is obviously got some environmental concerns behind it. Proof of stake is, in general, a lot cleaner way to do rewards for blockchain and doesn't require as significant of electricity consumption as proof of work. So we're seeing a trend where everything's moving towards proof of stake. Additionally, we've seen a wide variety of chains with unique requirements, right? So not every chain requires the same cookie cutter solution, and that's one of the reasons, Alex was saying that they need to partner with all sorts of different organizations to make sure that they're getting exactly what they need. And that's why DigitalOcean, we'll talk about this in a little bit, DigitalOcean provides a variety of different services, especially compute types, to try and match the majority of those blockchain requirements. Additionally, when we talk about infrastructure requirements, we're talking about storage and compute, right? Those are requirements that every blockchain storage and compute requirements grow continuously as that blockchain matures. So that's certainly something that, especially storage, not going to go down in size unless you're taking a light node or something like that. Additionally, more relays are being run. This is a practice that we see more and more. So just another type of workload that you can run and has specific resource requirements. Relays not as compute intensive as, for example, a full node. And then we've seen databases be added more and more to track node status, right? So if you have a bunch of nodes that you're running, you want to track exactly how those nodes are behaving. Databases, relational databases are built for that, for maintaining information about various items. So we've seen a lot of Postgres and MySQL workloads come through in relation to blockchain, not handling the blockchain itself, but handling the nodes which are handling the blockchain. And then finally, in terms of classic, archetypes of infrastructure and needs, we've seen that the blockchain workloads have really similar profiles when we're talking about a full node to a large database. And that makes basic sense when you think about it. A blockchain is essentially a distributed database, right? We call it a distributed ledger, but a ledger is a database, right? It stores information about everything going on in that particular system. And so blockchain workloads, large database workloads, very similar when it gets down to the actual big full nodes. So next slide, please. Great. So I talked a little bit about this on the last slide, but there are tools that we're seeing everybody leaning into when it comes to blockchain workloads. And we work with a lot of larger blockchain users and some small blockchain users, but across all of them, we're seeing the same stuff. We're seeing custom images are being used to speed up how fast they deploy, right? Like we said, scaling fast is critical. We're not talking about scaling fast in terms of a day. We're talking about scaling fast in terms of seconds, right? So having an image already built out with all the stuff you need on it, so you don't have to install and configure, also helps, right? We use the Ansible and Packer and tools like that, but having that image built out will save you some time, especially if you can cache it in some way. We see people using, obviously, virtual machines, droplets at DigitalOcean for compute, storage, and network resources. These are obviously the core features of blockchain, so people must use some sort of compute resource to run their blockchain. And that seems like an obvious thing to say, but it really is an important consideration who you're getting compute from, because there used to be this idea in the infrastructure community that compute was becoming commoditized, and as a result, it wasn't going to matter who you. That's not true. We've seen, as a matter of fact, that's not true. It matters who you get your compute from. That affects the reliability, the performance itself, and just how pleasant it is to work with that provider. Additionally, we've seen, like I said before in the previous slide, we've seen relational databases like Postgres and MySQL taking off in terms of their usage to track node status to make sure that all of the nodes that you are running efficiently and not having a bunch of downtime, things like that. And these next two bullets, the infrastructure as code, that's what IAC is, infrastructure as code for repeatable environments. Packer, Terraform, Pulumi, configuration management through Ansible, Chef, and Salt. These are part and parcel with blockchain. Nobody's going in and manually running commands to set up these blockchain droplets. They are built with these configuration management tools. Additionally, you must have a robust API. We talked about earlier, things are being automated, not just with the configuration management, but with the infrastructure provisioning itself. Having a robust API that you can use and understand, and API tools on top of that, like DOCTL, make things significantly easier when it comes to deploying, tracking, and maintaining your blockchain workloads. And finally, we talk about all this as though each person is going to go out and stand up their own blockchain. You don't have to, right? We just heard from QuickNote a minute ago from Alex in terms of there are providers out there who can manage your blockchain for you, right? Just like you would use a managed database, because you don't want to learn database administration technology and skills. You would use a managed blockchain provider because you don't want to learn how to run a blockchain. It's totally reasonable. We see it. Obviously, they're doing business for a reason. This is a valuable service that they found that people can use. Next slide, please. Great. So I wanted to talk about a few different products that DigitalOcean offers and how they can apply to some of these different blockchain workloads we've been focusing on. So first of all, the compute and storage requirements obviously differ, and as a result, DigitalOcean has multiple different droplet types with different types of compute and different types of storage. So when we talk about light nodes up at the top, those are the nodes that don't have the full blockchain, that aren't doing the entire blockchain workload. Those can be on shared or dedicated threads, right? So we recommend dedicated because with shared threads, you could get that CPU steal we talked about earlier, but it absolutely is possible to run a light node on a shared thread. A full node, on the other hand, one that maintains an entire copy of the blockchain and validates transactions, those we see really heavier requirements for dedicated threads. You don't want to put that on a shared thread system because if you do see that CPU steal, then you could have downtime for, essentially not able to process transactions quickly enough for your nodes, and as a result, you get deprioritized in the network, you get other penalties, things like that. So don't want that. The whole point of participating in the network for many of these workloads is to be a reliable provider in the network so you can continue to get rewards regularly. If you're not a reliable provider in the network, you're not getting regular rewards. So absolutely critical that you are putting those full nodes on dedicated threads. Bridges vary completely by chain and configuration, and this is something I would encourage people to test out, right? Absolutely something you can run yourself on your own account. Just try running a bridge, see what that's like. We see a lot of people, Pocket is becoming very popular as a chain, and they run bridges, so you might want to check that out. It's a very interesting field. Proof of stake workloads, funny enough, they can run on shared threads just fine, whereas we see proof of work on the other side absolutely needs not only dedicated threads, but GPU threads. Whereas proof of stake, because it's not doing all this complex computation, really can run on shared threads without much risk of you losing access to or having downtime as a result of not being able to process the transactions. Any other proof but proof of stake essentially is going to be a dedicated thread plan. Any other proof requires a lot more work be done to validate the transaction, and so as a result, we recommend they be on dedicated threads to give you guys maximum usage. Archival nodes. So you may not know what an archival node is. An archival node is where you can store the blockchain and when you need to retrieve it, but you don't necessarily want to have it, on a full node, right? So, or with archival nodes, we recommend block storage. So block storage is expandable storage up to 16 terabyte drives right now per region or per droplet, per volume, I should say. And so absolutely a great way to less expensively expand your storage so you don't have to go all the way up to a huge VM plan. You can go with a smaller VM plan and just expand your block storage on the side there. And then finally, again, I keep hammering this in, but node tracking. We see relational databases like Postgres and MySQL popping up all over the place. Honestly, I think, every blockchain customer that I've worked with recently is using a relational database to track their node status. So I talked in the points down below are essentially rehashing of what I was talking about above in terms of what are the right resources. And I just want to hit again that all of this is usually handled with automation. Tools like doctl and those other configuration management and API interface tools, absolutely incredible. DigitalOcean is a registered Terraform provider, so there are scripts already out there, test scripts you can run, try out Terraform yourself, see how you like it on DigitalOcean. Next slide, please. So this is an example of a super genericized but full blockchain workload, right? So you can see we have a light node group on the front end, and that's where users interact by default. But then, of course, we've got a bunch of other supporting services, right? So the full nodes on the back end with the actual full copy of the blockchain. So you may see the light nodes in front be shared thread droplets. We may see the full nodes in the back. We'd almost certainly see those be dedicated thread droplets just to ensure that they have full performance. Additionally, we see the supporting services on the bottom. We see the state storage through MySQL, or it could be Postgres. We see the volumes, which give some, if you want to add archival storage to your systems, for example, the light nodes can use volumes to store a bigger copy of the blockchain and maybe not have to do as much on the full nodes. And then, of course, both of these groups are supported by the supporting services like Ansible, Packer, doctl, Terraform, things like that. And then, obviously, what I think about it is interesting about blockchain diagrams as opposed to, a traditional infrastructure diagram is a blockchain diagram always has the external user coming in one side, and then always on the back end, it's going back to the blockchain network, right? So it's sort of a two-way chart, which is I always think is interesting in terms of how it differs from other examples of infrastructure. Next slide, please. So why, all of these things that I've talked about, they could probably be given to you by multiple providers, but why in particular is DigitalOcean a great choice for your blockchain workloads? We'll talk about a few things. One, we're a Terraform provider. Not everyone can say that. We do have a registered Terraform module, so you can use Terraform with DigitalOcean with very little setup. There are guides for it. I strongly recommend you check those out. Additionally, we have an Ansible module. Same reasons, right? So Ansible is one of the most popular tools we see. It's had great longevity. Strongly encourage you to check out Ansible. So to be clear, Terraform provisions the infrastructure. Ansible then configures the infrastructure to run in the network that it's in and have the software it needs to run. We have a straightforward API and services. I think anybody who's familiar with DigitalOcean knows that we have a reputation for simplicity. We keep things simple. We keep it easy, not only from a usage perspective, but from a billing perspective as well. Everything is as simple as we can make it for our customers, and as a result, it's easy to get started. Additionally, it just goes to our transparent. It speaks to the same point. Our transparent pricing allows you to get started without having to worry about, okay, if I start running this blockchain node, am I going to be paying $3,000 at the end of the month without realizing it, even though I started at 10? So it absolutely helps to be able to plan out very specifically how much you're going to pay. DigitalOcean gives you those tools. And then finally, custom image support. So custom images are, like I said, they can help you stand up much more quickly from a rapid scaling perspective. And as a result, we see them used all the time in blockchain workloads. You're still going to perform configuration on them because obviously you need to add it into the rest of your services and connect it to everything. So you're still going to use Ansible or a tool like that. But having that custom image right out of the box allows you to start that up a lot faster. And then finally, a cloud agnostic attitude. DigitalOcean, we are a cloud. We do compete with other clouds, but we also believe that fundamentally customers benefit when they are able to be multi-cloud. We, as a result, run as much open source software as we can. Most of the things that we build are designed for customers to be able to take everything from and leave or copy somewhere else. So you're not getting into a moated system when you come to DigitalOcean. There is absolutely freedom to move around and have a distributed blockchain workload across multiple clouds. Next slide, please. Perfect, yeah. And then a global presence, which is what I wanted to show on this slide. This shows our data centers all around the world. This is from, obviously, San Francisco, Toronto, New York, London, Frankfurt, Amsterdam, Bangalore, Singapore. We are opening up, I think I can officially say this because Yancey, our CEO, mentioned it on an earnings call recently. I can officially say that we are planning on opening a Sydney data center. So we're very excited about that to give folks an additional endpoint there. We know that the Australian community is underserved right now in terms of data centers. Next slide, please. Wanted to mention just a few of the popular chains we're seeing. This isn't necessarily an infrastructure question as much as just talking about kind of interesting trends in the blockchain community. You'll see that we have Ethereum, which is everybody's aware of Ethereum. That's an extremely popular token or network right now, and we see it used all the time. It has cool smart contract functionality. You'll notice that of all of these, Ethereum is the only one that is proof of work, and that's kind of the elephant in the room when it comes to Ethereum. They are trying to move to a proof of stake system with Ethereum 2, is my understanding, because they also see the writing on the wall that proof of work is probably going the way of the dinosaur. Elrond is another really interesting chain that we see on DigitalOcean. They are enterprise-focused blockchain, focusing on distributed apps and using proof of stake. So when we say distributed apps or DApps, we're talking about applications that are built on the blockchain that can be all over the place. I'm not going to get too into that, but what's interesting about that is that how many enterprise workloads can make use of that type of technology. So Elrond is really pushing into new ground in that space. Cardano, you may have heard of before, another distributed application chain provider, also very popular. We're seeing it pretty consistently. They focus on, I shouldn't say focus, they are certainly present in supply chain management, credential verification, anti-counterfeiting operations, right, making sure that the goods you're getting are the real goods and not shipped in from somewhere else through supply chain interdiction. And then we talked a little bit earlier about the Pocket network, right, which is a bridge between chains. Pocket facilitates transfers of tokens between chains. It's a proof of stake network. It's a really interesting concept, and it's getting a lot of popularity in the enterprise level in terms of you can stake this coin and make a decent amount in return as a result. So very popular, very good chain. I encourage you to check it out if you haven't already. Presearch is another really interesting one. Most interesting to me is that they reward users who perform searches on the search engine. So Presearch itself is a search engine, distributed search engine, and they reward people for making searches because making searches makes the engine better. It's a really interesting concept there that I'd encourage you to check out as well. Next slide, please. So we had some frequent complaints and concerns about blockchain from just in the general community that we wanted to talk about and kind of how DigitalOcean helps alleviate those. First of all, what will my bill be, right? What am I going to be paying here for this blockchain workload that I'm running? It's not necessarily easy to calculate how much I'm going to make in all cases from this, depending on my uptime and things like that. So I really want to know how much I'm going to spend so I can at least get a ballpark. Will performance be consistent and reliable? This is a great, this is really important. If you don't have consistent and reliable performance, then you're not going to get rewards consistently and reliably on the network either. So reliable performance, consistent performance, uptime, critical. If you don't have that, you do not have a successful blockchain network. One of the questions with this is ECC RAM being used in my environment? Error code checking RAM. That's usually you want that. Most data centers today are going to be running ECC RAM. DigitalOcean runs ECC RAM. But if you're running non-ECC RAM, you can have increased errors in your memory, which can cause you to have verification errors, which can cause you to be kicked off the network and not get rewards. Global interconnectivity, a critical piece here. You need to have locations around the world so that people can access the network quickly. Now, the good thing about blockchain is that by default it is globally interconnected, and that's the whole point of having a distributed ledger. If you want to build a blockchain network of your own that people can access, then having global interconnectivity is fantastic. It's required. Obviously, you can't be in somewhere that doesn't allow connections to the outside world. Flexibility and scaling. We talked about this a couple of times already, but it really bears repeating. How fast and how accurately you can scale to your needs, that's your margins right there. If you can't scale quickly enough, you're not going to get the rewards from the blockchain network. If you are scaling too fast, then you're going to be paying more for infrastructure than you need to pay. So understanding that specific scaling model is critical. And this is where bare metal versus cloud comes into the conversation, right? So again, bare metal is great in terms of cost, but it's super inflexible in terms of scaling. So blockchain workloads are generally not a good fit for bare metal. And SOC certification, right? You need to know that you're working with a data center provider, infrastructure provider who has excellent top quality security and controls and can keep your data safe. And then finally, the global availability, which I actually talked about earlier, so it looks like I duplicated my bullets there, so sorry about that, folks. But let's tie this all together, right? So all these things I've talked about multiple times, we'll bring them all together here. First of all, you should have an automated workflow. We recommend Terraform and Ansible. Packer's also a wonderful tool. You can use things like doctl in your application as well. DigitalOcean Container Registry for storing images. If you are deploying from container images, the registry is fantastic. It gives you super fast stand-up times, which we've talked about is really important for rapid scaling. A Neighbors API. This is a cool tool that DigitalOcean offers so that if you are running very large blockchain nodes and don't want them to compete with each other, you can actually make an API call to DigitalOcean's API that asks, are these droplets neighbors with each other? This is something that our blockchain customers often use to ensure that they are not stealing from themselves, so to speak, when they are eating up a bunch of resources on a hypervisor. Different virtual machine types for different blockchains, absolutely critical. You need to understand the type of node that you're running before you make a decision on what infrastructure is going to run it. If you're trying to run a full node on shared threads, you're going to have a bad time. You're not going to get rewards from the network because you're going to be constantly failing to participate. And then finally, deploying globally. Again, wherever your customers are. If you have a blockchain, if your customers of your chain are primarily in Singapore and you're deploying in New York, you're doing it wrong. Be where your customers are. Next slide, please. So, closing thoughts, the cloud gives you tools to be super fast and super flexible when you're deploying blockchain compute resources. DigitalOcean offers supporting services to help you build those blockchain businesses. And as Robert mentioned, please reach out. We'd be happy to talk to you about the trends we're seeing, the things that we can help with, different answers to questions that you may have. We have heard all the questions before, I promise you that. Because the growth is explosive and unpredictable for blockchain, certainly explosive right now, it requires a flexible provider. It requires a provider who can work with you to ensure that you have the capacity you need in advance of when you need it. Blockchain is here to stay and grow, right? It's not going away. Some people might have thought that blockchain was a fad, that it was going to fall off. Blockchain is not the fad. There may be fads that are related to blockchain, but blockchain itself is not the fad. It's definitely going to stay. It behooves you to learn about it and potentially to get on blockchain. And again, as we see, non-proof of work workloads are skyrocketing right now, especially proof of stake workloads. We're seeing a lot of chains moving to proof of stake. It seems to be a model that makes sense to a lot of them. And then lastly, finding a provider who offers supporting tools, service, and flexibility to build your business is critical. If you're working with a provider who does not care what you're doing, you're going to have a bad time. That's just the way that works. You need somebody who's attentive, who knows what you're doing, and who understands the business in which you're operating. DigitalOcean, we hope, can be that provider. Next slide, please. I will hang out and be in the chat for a little bit here, just in case anyone has any questions. But thanks so much for your time. I really appreciate you tuning in. And again, please don't hesitate to reach out, as Robert mentioned in the chat, and I'd be happy to talk to you as well.